Another way that we can define sequences is with something called a recursive sequence. A recursive sequence is one where the term, whatever term you're trying to find, is determined by the numbers before it. So in order to use a recursive sequence, you need to know at least the first term, sometimes more than that, and then a rule for how to get the next term. Now, something really important, I think we switched to K's on this, which is fine, is if we are talking about the term AK, the term that comes after AK is AK plus 1, and the term that comes before AK is AK minus 1, and the term before that is AK minus 2, and so on and so forth in both directions, okay? So that's something important to think about when we're doing these. So we want to find the first 5 terms of the sequence, and this is the formula that they've given us. So they are telling us the first term is 6. Great. We know the first term is 6. And then it's saying to find AK plus 1, you take AK and add 1. So this is saying if you want to find this term, AK plus 1, you have to take AK, which is the term before it. So what this formula is saying is take the term before and add 1 to it. Okay? So if you want to find the second term, you take the term before and add 1. And then the next term, take the term before and add 1. And you can see this is a very simple sequence. Okay? Let's try a more complicated one. The next one, A1 is 3. This sequence starts with 3. And then it's telling you if you want to find AK, you have to take 2 times AK minus 1 plus 1. So this is telling you, look, if you want to find AK, you have to take AK minus 1. So this is the term before. So we're taking 2 times the term before and adding 1. So over here, to find the second term, I'm going to take 2 times the term before and add 1. And then I'm going to take 2 times the term before and add 1. And then 2 times the term before and add 1. And 2 times the term before and add 1. This is 62, 63. Okay. All right. I think I have one more of these. Let's get this page to slide. We want to write the first 6 terms of this sequence. This one's defined a little bit different. The 0 term is 1, which is fine. The first term is 1, so 1, 1. Those are our first 2 terms. And then, what are we doing here? AK, if you want to find AK, you take AK minus 2. That's 2 terms back. And you add it to AK minus 1. That is 1 term before. Okay, so if you want to find AK, you have to take the number 2 terms back and add it to the number that's 1 term back. So if we want to find this, we have to take the number 2 back and add it to that one that's before it. So 1 plus 1 is 2. I might switch colors here. To find this term, we have to take the term that's 2 before it and add it to the term that's 1 before it. It's going to be 3. Then to find this term, we have to take the term that's 2 before it and the term that's 1 before it. That's 5. I think we need to do this one more time. Take the term 2 before and add it to the term that's 1 before. And that'll keep going. Okay. You may recognize this one. This is called the Fibonacci sequence. But the Fibonacci sequence is found recursively. You have to know the terms before it to find whatever term you're looking for. All right. A lot of times in sequences, you see factorials. Factorial should be super familiar to you. In factorial, you start with n. Let's do this first with a different number. If I asked you to do 5 factorial, you all know what that means. That means 5 times 4 times 3 times 2 times 1. Okay, so n factorial means you take n, and then the number before that, n minus 1, and the number before that, n minus 2, and you're multiplying all of these all the way down to 1. Okay, so that's the definition of factorial. Something that you need to know is that 0 factorial is 1. That's a little counterintuitive, but it is 1. You can try it on your calculator too. It'll tell you the same thing. So we have a sequence here that has a factorial in it. We want to find the first 5 terms. So remember, to find A1, we're going to plug in 1. So 3 to the first plus 1 factorial. So that's going to give us 4. A2, we're going to do 3 squared plus 1 over 2 factorial. So 10 divided by 2, which is 5. To find the third term, plug in 3. So that's going to give us 28 over 6. Will be 14 thirds. The fourth term, 3 to the fourth plus 1 over 4 factorial. So it's 82 over 24. I'm getting real tired of reducing these. 41 twelfths. And A5, 3 to the fifth plus 1 over 5 factorial. I think that's 243 over 120. I don't know. Does that reduce? Question mark. I don't know. Okay, so those are the first 5 terms of that sequence. 4, 5, 14 thirds, 41 twelfths, and then whatever this was, if it reduced. I don't know if it does. It does. It does. They're both divisible by 3. All right. Simplifying with factorials. So we can do factorials in your calculator. If you're working with the scientific calculator, you probably already know where your probability menu is. If you have a graphing calculator, go to the math menu and then arrow over to the right to probability, and you'll see your factorial button. So anyway, you can do this in your calculator. I don't happen to have a calculator, so let me show you another way you can do this. So 8 factorial is this. I'm just going to write those all out. 2 factorial and 6 factorial. Now, since these are all multiplication, you are allowed to cancel. Notice those all cancel out. So we end up, you know what, and even 8 is divisible by 2. That's going to make my number smaller. Okay, so this is going to give us 28 as an answer, which is fantastic. My dog is sitting next to me and apparently dreaming about something. So if you hear barking, it's sleep barking. I don't know what's going on. All right, n factorial. N factorial is n times n minus 1 times n minus 2. And that's going to keep on going till, it gets down to 1. N minus 1 factorial starts with n minus 1. And then n minus 2, and that's going to keep going. And since these are all multiplication, everything cancels except the n. So that's just n. All right, let's check out C. 4 factorial, that's easy, we know that one. N plus 1 factorial is going to start with n plus 1. The next number down is n, and then n minus 1, and then n minus 2, and that's going to keep going however long it needs to go. 3 factorial, that's easy. N factorial starts with n, and then n minus 1, and then n minus 2, and that's going to keep going. And now we can cancel stuff. N's cancel, n minus 1, n minus 2, so our answer is going to be 4, n plus 1.